Hello everyone. It's indeed inspiring to have a discussion on applied machine learning. This is the agenda: introduction, data, big data, getting familiar with terminologies and concepts, examples of various learning paradigms. Data. We all know that data, the basic definition of data is raw facts and figures. And once you process this data, that is actually called as information. We have mobile devices where we have images, videos, audios, and documents which we see as day-to-day data. We have social media platforms, and there also we are contributing a lot to generate data. Businesses have got websites, individuals have got blogs, so they also are contributing in generating data. Now the question is, why do we call it as big data now? Right, because this is all data. So why do we call it as big data? That is one question to be discussed. And in the slide I have written that it is a challenge as well as an opportunity. So we'll justify these things. This is a definition from Gartner. It says that big data term is applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable elapsed time. Okay, now here basically we can understand why do we call it as big data, because these data sets are so large that the commonly used software tools, they have no capability to capture, manage, and process this data, and that too in a given timeline. Gartner also makes a prediction that there will be 800% more data in the upcoming years, and most of the data which is being produced is unstructured. That is a challenge. Okay, now what are the factors which make data as big data? The three factors, these are the primary three factors: volume, velocity, and variety. You can look at the another video where we have discussed in detail these three factors, as well as there are certain more factors which we have discussed. Volume contributes to the data which is stored at this particular point of time in the servers, in the data centers. Okay, velocity is the speed at which data is being growing. If you open up your social media, you will see that a lot of posts are there, a lot of messages are there. So that is the velocity, that is called as streaming data. Then we have structured, semi-structured, unstructured, different types of data. Like you see that Excel file is structured, semi-structured is XML or HTML. Then we have unstructured data like your notepad. Okay, so these are the factors which make data as data. Fine. Now there is a terminology which is called as data science. So this data science concept is basically whatever you do with data can come under data science. This is like the rooftop. Okay, it comes on top most. So if you are studying data, you are basically working under data science. If you are exploring data, if you are doing some calculation with data, you are applying some algorithm with the data, you are cleaning the data. So whatever you do with the data actually comes under data science. Okay, so science basically is study of something, exploration of something, experimentation of something. Okay, so here this something is data, right? So whatever you do with the data will come under data science. This is a definition of data science. Data science is a multidisciplinary field that uses scientific methods, processes, and algorithms and systems to extract knowledge and insights from structured and unstructured data. Okay, so from here you can understand that it is a multidisciplinary field. Okay, so a lot of things actually come under data science. Okay, it uses scientific methods, processes, algorithms, and systems. So it is using some methods, some processes, some algorithms as well, and some systems, some software also it is using. Okay, so whatever you do with data is actually coming under data science. Okay. Now, another definition from the website datarobot.com, it says that data science is a field of study that combines domain expertise, programming skills, and knowledge of maths and statistics to extract meaningful insights from the data. Okay, so from here, try to understand the phrases. Domain expertise is one thing, okay, then programming skill is another thing, and then knowledge of maths and statistics. Okay, so these three things combined together can make you a data scientist. In turn, these systems generate insights that analysts and business users translate into tangible business value. So the ultimate objective is that we can derive some meaningful insights from the data. That is the ultimate objective of data science. Okay, now after data science, there are so many terminologies, like we have data mining, we have business analytics, we have business intelligence. So let us quickly understand what exactly these terminologies actually mean. Okay, so this is a brief history. In 1763, okay, Thomas Bayes, so he developed an algorithm, Bayes theorem, okay, so that works on probability, conditional probability. Okay, and then after that, 1805, Adrian Mary, Legendre, and Carl Friedrich Gauss, they actually came up with the regression analytics. Okay, after that in 1936, it was the dawn of computer age. Then Turing test, Alan Turing, he came up with a universal machine, and that is one of the most popular tests that identifies whether the response you are getting from a machine or the response you are getting from a human. Okay, so if you are able to identify that, okay, which one is machine's response and which one is human's response, then basically the test fails and basically machine is not intelligent. But if you are not able to identify the response from the machine and the response from the human, okay, that who is giving which response, then basically we will term machine as intelligent. So that is a test basically Alan Turing has developed. 1943, Warren McCulloch and Walter Pitts, they actually came up with the concept of neural network. So this is a brief history how basically it got evolved. Now the second terminology we have is data mining. Mining, in English, mining means extraction. Okay, and what we are mining here, data. So here data means useful information. So extraction of useful information from the raw data, that is actually called as data mining. Okay, let's read the definition. Data mining is the process of discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and database systems. Okay, so if you see that, it is very similar to data science. Okay, so don't get confused. Whatever you do with the data comes under data science. It's very clear. Okay, so there is no debate. Okay, there is no basically question. If you do something with data, it will come under data science. Okay, here basically in case of mining, okay, you are using certain algorithms and you are using statistics as well. Okay, so algorithms can come under machine learning. Okay, so some algorithms you are using, some logic you are building and applying it on the data. Okay, at the same time what you are doing, you are basically applying statistics also. Okay, and data, yes, some database systems would be there or some file systems would be there where data will be stored and you will be processing over that particular data sets. Okay, after data mining, okay, next is, let's say you create a logic, okay, and you put that logic into a machine. Okay, taking example of automatic vacuum cleaner. Okay, so the logic is we can identify the dust particles and as a human being we can clean the dusty surface. Okay, if the same logic can be applied to a machine, now basically human efforts are reduced, the machine is intelligent enough to identify the dusty surface and it can clear out the dust. Okay, so this is basically called as artificial intelligence. Why do we call it as artificial intelligence? Because the logic which human applies to clear out the dust is now the machine is able to apply. Okay, fine. So if the machine is able to think humanly, machine is able to act humanly, we call the machine as a product of artificial intelligence. A second definition could be, if the machine can act logically as well as think logically, then also we will call the machine as intelligent machine. Okay, so John McCarthy, he basically coined the term artificial intelligence in 1956 when he invited a group of researchers from a variety of disciplines including language simulation, neural nets, complexity theory and more to a summer workshop, and the workshop was Dartmouth summer research project on artificial intelligence to discuss what would ultimately become the field of AI. So that was the basically discussion going on in that particular meetup, okay, workshop. Fine. Now basically there were a lot of things which were being discussed, like thinking machines, intelligent artificial intelligence, information processing. Okay, so a lot of terms were discussed, but artificial intelligence was coined here, okay, as an appropriate terminology. Now the dictionary in the English Oxford dictionary says about AI: the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Okay, So this actually requires human intervention to perform such kind of task. Okay, we can easily identify a dog and a cat. Okay, why? Because that capability has been given to human beings. Okay, if the machine can do the same thing, then basically we'll say that the machine is intelligent. Okay, another website. Okay, Merriam-Webster defines artificial intelligence as a branch of computer science dealing with the simulation of intelligent behavior in computers. Okay, so mark that word, simulation of intelligent behavior in computers. Okay, the capability of machine to imitate intelligent human behavior. This is basically called as artificial intelligence. Now, after that, let's say, let's take example, we have dogs, we have cats. Okay, so as a human being, okay, we are able to identify dogs and cats, but for a machine it becomes very difficult, because to a machine we will have to give this logic. Okay, we'll have to give a lot of input, lot of images of dogs, and we'll have to train the machine that these are the images of the dogs. Okay, and on the other hand we'll have to give multiple images of the cats, and we'll have to train the machine that these are the images of the cats. Okay, so this is something we'll have to help the machine first, and then basically based upon that learning machine can identify. Okay, so after artificial intelligence we have the next concept called as machine learning. So machine learning is the capability of learning given to the machine. Let's take example of a small kid. If a small kid is walking down the stairs and let's say the kid falls down, what will happen in the next time? Okay, next time there can be two chances. The kid will refuse to walk down the stairs, or because kid is a human being, that time kid may sit on the stair and would try to get down by sitting itself in the sitting position. So what he did, he basically learned from the past experience that if I would walk down the same way I was doing earlier, I will again fall down. So falling down is a kind of reward the kid got. Okay, so this time the kid will try to attempt a different way. Okay, so this is basically learning ability in human beings. If machine can learn from the past experiences, okay, then basically we call that machine is intelligent, as well as machine has got learning capability. Google Maps, if you see, so Google Maps have got learning capability. They keep on taking feedbacks from the user as well. Why? Because they want to learn and they want to suggest and they want to tell the next route or next suggestions to the user in a better possible manner. Okay, so machine learning again is a specialization of artificial intelligence. Arthur Samuel in 1959 basically he coined this term machine learning. Okay, he defined it as a field of study that gives computers the ability to learn without being explicitly programmed. So understand, okay, so the program itself is created in such a way, okay, we call it as a model. That model itself learns from the data, from the experiences. Okay, machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Okay, machine learning focuses on the development of computer programs that can access data and use it, learn for themselves. Okay, so this is the definition of machine learning. After machine learning we have another terminology which is called as deep learning. Deep learning is again a specialization of machine learning, or you can say it is a subset of machine learning, because deep learning specifically focuses on neural networks. Okay, human body has got neurons. There are so many neurons, they are the cells basically, and they are connected to another neurons. One neuron may be connected to hundreds or thousands of other neurons. Okay, and therefore they create a neural network. So as soon as, let's say, you touch a very hot plate, what happens? Immediately your hand gets back. Okay, so brain need not to think also to decide that the hand needs to be taken back. Okay, it's a spontaneous action. Okay, so this basically capability comes with the help of the neural network which human beings have. Okay, so they have a special learning ability. So the same kind of approach in machine learning is called as deep neural network. Okay, or deep learning. Let us now understand there are different learning paradigms. You can see that supervised learning, ensemble learning, unsupervised learning, probabilistic learning, and reinforcement learning. Supervised learning is based upon the data where we have a set of inputs and there is already a mapping of set of outputs with the input. So if we have a data set with input and output given, we call this data as labeled data, and that is basically supervised learning. After that comes ensemble learning. Ensemble learning means there are group of algorithms, or we can say that there are group of models where some algorithms perform better, some algorithms they do not perform better, but when we group them as a group, as a cluster, that is basically an ensemble, so as an ensemble they perform better. Okay, so that is called as ensemble learning. Unsupervised learning, here we have data, but the data is not along with the output. So only input is there, input is not mapped with the output. So therefore we call this as unsupervised. Okay, in contrast to the supervised learning. We only have some data, but we don't have any output. So the learning becomes difficult for the algorithm in this case. Next one is probabilistic learning. This works on, as the name suggests, probability. Naive-Bayes algorithm is one of the example of probabilistic learning. Next one is reinforcement learning. As the name suggests, reinforcement, it basically learns on the basis of the output it produces, and with the output it gets some kind of reward or feedback. So with that particular feedback it learns, and then the next output is a little bit better. Okay, so that is the approach of reinforcement learning. Wait for the next videos where we will discuss in detail each of these paradigms. Thank you.
If you liked our video and would like to recommend it to your friends, please like, share and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.